Hello, this is Dr. Satish Singhal, PhD, Professor of Computer Information Technology at Rose State College in Oklahoma City. Uh, I want to show a loan payment program in C Sharp. First, I want to show all the math and conversion of math expressions into C Sharp source code, and then I want to code the program in Visual Studio 2012 C Sharp, so that way all the watchers will be able to see all the steps of this kind of program. Okay. Well, let's talk about financial calculation formula in general. Financial calculation formula are often long and have divisions and power expressions, and of course multiplication and addition. And bankers very often approximate them to simplify, because bankers have to deal with a lot of ordinary people who do not have detailed math background, so bankers often simplify them. But in process of simplification, the accuracy is lost, but calculations do become simple, so people can understand the calculation a little bit easier. Very famous simplification is the rule of 72 for the compound interest, which says that if you divide 72 by annual interest rate at which you have deposited your money on the compound interest, then your money will double that many years. 72 divided by annual interest rate. That's called rule of 72. That's one of the simplification. But we are software developers and engineers. We cannot afford the inaccuracy of banker simplification, so we must use the original formula. So we must learn to use original formula, and that requires knowledge and strategy to convert mathematical formula to C# source code in C# language, and in other languages you will use other conversions accordingly. We'll take one such formula which is used to calculate monthly payments on a loan that a person might have taken. These kind of loans are taken when you buy a car, for example. Mortgage interest is a little different, although it might have some similarities. But when you buy a car and take a car loan, it's pretty simple that this kind of formula is used in those cases. Okay, so formula for a monthly payment on a loan is given as below. On left hand side we have month PMT, and you get a little bit of a, I guess I'm not getting the pen here, that's okay. So my monthly payment will be equal to, on the top the numerator is this expression, that loan multiplied by first term is rate divided by 1200, second term is 1 plus rate divided by 1200 to the power, so this part to the power num payment. Num payment is number of payments that will be made throughout the life of the loan. So that's the numerator. In denominator we have this expression, minus 1 plus exact same thing, 1 plus rate divided by 1200 to the power num payment. And once again various terms in the formula are as follows. Month PMT, which is on left hand side, is the monthly payment due. Rate is the annual interest rate. Rate has appeared 3 different times, here, here and here. That's annual interest rate in percent at which loan has been granted, and this could be a fractional quantity. Num PMT is the total number of payments to be made by the user over the life of the loan. So we can calculate it as follows. By the way, this will be a whole number, so let's once again become clear what our whole numbers are and what could be fractional numbers. Num PMT will be a whole number. So how can we calculate num PMT? For example, if user took 5-year loan and payments will be made monthly, then 12 payments per year for 5 years, so 5 into 12 is 60. So there will be 60 payments made. Okay, so that will be num-PMT. So user is going to provide us the amount of loan they took, rate, annual interest rate, and the number of payments they'll be making. And that's the basis of finding monthly payment. So when you go to car dealership and they say, okay, how much monthly payment can you afford? And if life of loan is 5 years, well then if you can afford low monthly payments, well they're just going to jack up your interest rate accordingly to get the total paid over the life of the loan. Now this formula, okay, why am I somehow my okay, I'm losing my, okay, let me see, why am I losing my, my mouse was getting lost. This formula is a bit complicated and we're going to simplify it by a method called substitution. Okay, in fact there is nothing stopping us from getting the loan amount, rate, and num payments from user directly and plugging into this formula, but for some people some sort of simplification might help understanding a little bit more. So simplification step use something called a substitution method, and we show the substitution method now. Okay, so here is our formula whose right side needs simplification by substitution. Left side has to be calculated, so no substitution required there. But this is, once again, this is our right side, numerator and denominator. So when you simplify by substitution, you look for common expressions and replace them by something simple. So we see rate divided by 1200 appeared here, here, and here. So first simplifying step is we substitute R for rate divided by 1200. Okay, so if we change R and place it for rate divided by 1200, this more complicated formula becomes somewhat simpler in this form. So R into 1 plus R to the power num payment, and this is minus 1 plus 1 plus R to the power num payment. And immediately we can see there is a second simplification step. Then we can replace 1 plus R to the power num payment because it occurred twice, once here and once there, occurred twice. Let's replace that by F. Then our formula becomes actually fairly simple, and it changes to month PMT equal to loan into RF, or this thing will replace by F, into minus 1 plus F or F minus 1, either one will be okay. So that's so far. But now the next step we have is to convert this into a C-sharp expression, all parts of it into C-sharp expression. So now we show you C-sharp source code for each substitution step until we reach the C-sharp source code for final monthly payment formula, because after all we have to write a C-sharp program using this formula. And table in next slide shows us that. So R was rate divided by 1200. There's not much change here. All we show is, assuming that R has been declared before this line, we say R equal to rate divided by 1200 semicolon. Each C-sharp statement ends with semicolon. This requires a bit more. We did a substitution that F equal to 1 plus R to the power num payment, num PMT. Well, C-sharp does not have a hat operator, and we cannot write power like this the way we wrote in PowerPoint here. We cannot write power like that in the source code. So how do we take power in C sharp. We described that in another video, that we use a function or method called math.pow, in which first part is the base. So this is the base, 1 plus r. Second part is the numpmt, which is the power. So base, comma, power. These two arguments are passed to the math.pow, and basically when we write this in C sharp, exactly this operation will be done, ending with the semicolon. So now my original formula was this, and of course f has to be declared before we use this. So my month PMT formula, which was like this, ln into r into f minus 1 plus f, becomes each bracket has to be changed, or blank space has to be changed with asterisk. So it became ln into asterisk into r into f divided by minus 1 plus f. Don't forget the asterisk. That's a huge mistake generally translating from math formula to C sharp formula. Forgetting the asterisk is a major problem. Okay. So in actual program, before we write this expression, r has to be declared. Before we write this expression, f has to be declared. Before we write this expression, month PMT and ln has to be declared. Okay. Now we try to figure out what kind of data type we're going to have for each type of variables, r, f, month PMT, and ln, and numpmt. Okay. So in C sharp, the rule is all money, okay, notice the word money has to be declared at decimal type. Any other type will be inaccurate. So understand, I will deduct points if money is not declared as decimal type. Okay, one more time, I will deduct points if money is not declared decimal type. Those who are not my student don't have to worry about it. You can do anything you like. My students, points will be deducted if money is not declared decimal type. But rate is a fraction, so that could be double type. So the interest rate can contain decimalized fraction parts. Loan is a money, so that has to be declared a money type, and its declaration technique will be shown later. Monthly PMT is money, that has to be declared decimal type, and it may or may not compute to a round number. NumPMT has to be int type because it's number of payments. It's a whole number. Whole number requires using integer type. R will be a double type because it looks like rate. Rate was double type. Rate divided by 1200 will be double type also. And math.pow returns a double type always. So f will be double type also. Okay. So these are the data type, and that's the reason. So my advice in all these computer programs has been, what has been my advice? Be a doer. Don't just be a viewer. Be a doer. Do all this we have done in this PowerPoint so far by yourself. That will help you a lot. Don't be just a viewer, be a doer. So do all this on your own. Develop a flowchart for the program for loan payment calculation. Develop a pseudocode from that flowchart, and develop a handwritten C# source code from above pseudocode. And we're going to show you in the part 2 of this video in C# video, the C# program. So we're going to go to Visual Studio and show part 2. So this was the part 1 of loan payment program in C#. Thank you.